Okay, you were asked to look at the problem assigned on Blackboard and figure out how we got certain parts, or write out in detail how they got to the solution, as the solution was simply a sketch. There are three primary parts. How do you go from ds vector to r d theta? Where do you get the vector sine theta I hat minus cosine theta j hat? And where did you get the vector minus cosine theta I hat minus sine theta j hat? Let's start with ds shown on the diagram. And I show it here, and I show ds pointing upward and to the left, and the small increment ds. And I take a few minutes to magnify it, and what you have here is my ds. Then I have the two radius vectors on the each side of the increment. The incremental d theta are the radius vector from point P to the circle, and theta, which can be the average of the lower and upper thetas on the increment. The magnitude of ds is the arc length ds. Now, how is the arc length related to the radius r and d theta? Go back and think about when you did some angular work. How did you relate r, theta, and s, where s is the arc length? No different for r, d theta, and ds. And we have that ds is equal to r d theta, which explains the r d theta in the equation above. Now, what is the unit vector associated with direction of ds? And I show here a purple unit vector in the direction of ds. And if you'll note, the unit vector that I have is minus sine theta I hat plus cosine theta j hat. And that's according to the diagram that I've drawn below. Now the question is, why is my sign different from the sign above? You should be able to explain that. What is the unit vector associated with r hat? And I show the unit vector along the radial direction. And I show it on one side of the increment. Then when we take the increment to be infinitesimally small, so it doesn't really matter. So what is that unit vector? Okay, once again, I draw it on the diagram here, and I look at where theta is, and I can immediately write down that that unit vector is minus cosine theta I hat minus sine theta j hat. And we note that it's pointing in the minus I hat direction and the minus j hat direction. So the vector portion ds vector cross r hat is solved. It is r d theta times sine theta I hat minus cosine theta j hat crossed minus cosine theta I hat minus sine theta j hat. At this point, you should be able to carry out and get the equations they got below, or at least understand how they got to where they did. End of problem.